Yes, sir. Yeah.
Okay, fantastic. So we were discussing about we will try to finish this possible if today. Okay. So because it's a most of a theoretical subject. Okay, theoretical topic, not much numericals. Like there will be few 1 or 2 markers. That's it. So in the last class we have discussed about we were discussing that what are the kinds of waves. So we were discussing communication devices, how we do the communication. So we learned that what is communication, okay, and what are the parameters of communications are there. What are the parameters? Parameters meaning is we learned what is the transmitter, what is receiver, correct? What is bandwidth? What are the bandwidth are there? What are the types of signals are there? Then also we learned what we call the noise, because whenever the any kind of signal is there, some sort of a noise will be there in that, which is unwanted signal. Then we discuss something called an attenuation, okay, amplification. So these are the few parameters that we learned. And after that we started learning about few things called that what are the types of bandwidth are there, what are the types of signals that we have, like our speech, what are the frequencies are there, then what is AM broadcasting, what is FM broadcasting, what is the mobile phones range, then we discuss what is the satellite range. All those things we have discussed, correct? So this is what a brief we have discussed till now. Today we are going to learn a very interesting phenomena we call how the wave is propagated. So the propagation of the waves. So let's discuss about the propagation of waves. Propagation of waves. What is the meaning of propagation? Propagation meaning is like we already know that we have the LC circuit, correct? We have the LC circuit. For an example, this is our LC circuit, and we already know that once we charge this capacitor, then the current in this is keep on jumping like plus minus. So this will go like this, then this will go like this will go like this. So it keeps on go here and there, here and there, here and there. And if we put a one transmitter here, let's say we have put a one transmitter. Now because of this transmitter, the electromagnetic wave will start propagating from one region to another region, correct? For an example, your phone is there, you are just making a call. Now from here, the moment you told hello, now that signal will be created here, and then it will transmit like this, it will transmit, correct? This is what. Now we are going to discuss what are the different methods are available to us, how the wave is actually propagating in the medium. So we know that for here we have the transmitter. So transmitter actually creates the signal into the required format, and here is the receiver. This is the receiver. Now in between, how this transmission is happening, we are interested to know that, correct? So let's see how this thing happens. So what we are going to do, let's say this is our earth surface. This is our earth surface. Now whenever you are talking from the phone or anything, what happens? Like we generally get some sort of an antenna. Okay, like we have the mobile antenna, mobile tower or something like we call. Okay, and from that mobile tower, what is happening? Whatever the signal which is coming here, mobile tower signal. So let's say whenever you are calling from your phone and it is reaching to the nearby tower, and from that tower, what happens? You are okay, na, Bhupesh?
Yes, sir. I'm
Okay,
okay.
okay. Yeah. So feeling sleepy still? Little bit?
No, sir. Nothing like that.
Okay. So whenever like this is the signal, now one way is like, so this wave will basically go like this. Okay, and let's say here there is a one more receiver. We have put a one more antenna. So what will happen? This will basically will be picked up by this. This kind of transmission we call ground transmission. Correct? We call ground wave, because this is actually traveling on the ground, isn't it? This is called a ground wave. Now another way of transmission what we can do is basically we call, so let's say from here we know our earth has the atmosphere. This is the one layer, this is another layer. Earth has the many layers, isn't it? And as we go away our density decreases. So let's say what happened, like from here we have actually did like this, and then that signal is coming something like this. So we sent a signal in this direction, and from here the total internal reflection happens, correct, in this case, and it came back. This kind of propagation we call a sky wave, because you are sending the signal in the sky. So when it is going in the sky, from there it is reflecting and coming back. We call a sky wave transmission, correct? Now, but when the frequency is much higher, when the frequency, like currently the TV frequency, phone frequency, they are much higher. So what happen? This kind of wave, this kind of propagation will not be able to work. Why? Because this wave will penetrate into the layers and it will go into the sky. Correct? It will go basically in the space. It will never come back. So whenever there is a high frequency, is there, what happens? This will go something like this. It will penetrate. And here we put a satellite. This is a satellite. Right? Satellite we have learnt in the class 11, detailed one. So this satellite, this signal will go, and this signal will be transmitted by satellite again, like this. So here we say this is like from here the data is there, whatever the message is there, you are uploading your data. We say na in our, sometimes in the internet say it is uploading, it is downloading. What is the meaning? The meaning is that whenever you are say uploading, means the data is actually going from here through satellite communication. It is reaching to the satellite. We call this is uploading. And then when you get that from the satellite, we call it as a downloading. So this is how the one more communication happens. We call satellite communication. Satellite communication. Correct? So these are the three basic type of communication that we do. Okay? These are the methods of propagation. Methods of propagation. These are the three basics. Now let's discuss in detail what are these, how this works, correct? What are the criteria on which they are dependent upon. Okay, so let's give it a shot. Are you noting down?
Yes, sir. Yeah.
Okay. Fine. Let's discuss now. First one we call the ground wave. Now we will discuss little detail. So the ground wave. How the ground wave transmission actually happens. So we know that this is our earth. On the earth here we will put a basically one antenna. This is the transmitter basically. And here we will put a receiver. And the wave will basically go like this. Ding, 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 ding. This is the wave which is going. Now, what happens generally? This kind of transmission is utilized for low frequency waves. Correct? Low frequency wave. When the frequency of the wave, so if you know any kind of wave, every wave has certain parameters. It has the frequency, it has the wavelength, which is nothing but from here till here. Correct? This is the wavelength. One complete wave, it is completing here. This is the wavelength. It has frequency, it has velocity. These are the different parameters. It is there. Right? So generally the low frequency is there. It goes from few kilohertz to few megahertz. For an example, like less than 10 megahertz. For this only it works. Now the question comes, why this happens? Why we choose low frequency wave communication from the ground wave communication? Correct, that's the question. So let's understand that. So what is happening here is, if you remember, we have learnt whenever there is a any kind of wave is there, so this will be the like a higher amplitude, we can say plus, minus, plus, plus, plus. All these are the plus, plus, plus. These are the minus, minus, minus. Correct. Now in the chapter number 1, when we were learning the electric charges, we learned whenever there are charges or the ions are there, we get a ionization. It get ionized. Correct. Induced charge get happen. So what happens in the earth also get here positive, 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 like this. So what will happen? Earth will become ionized because of this kind of transmission. And what will happen? Suppose if this wave is very close, let's say this is the earth. Let's say this is our earth is there. Correct. This is the, assume this is the earth surface. This is the earth surface. Now here is the wave coming. Ding, 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 wave coming. Now in this case, what will happen? This is the minus charge. This is the plus charge. There will be a short circuit. This will basically, sometimes if the wave touch the ground, there will be a short circuit. Correct. So if there is a short circuit, what is going to happen? Initially, so when the transmitter, you have sended the wave like this. Correct. So let's say here the 100 waves are coming as a bundle. What will happen? From the 100, 5 got sorted here, 5 got sorted here, 5 got sorted here. So like that, what will happen? The strength of the wave will decrease. So what we will see, that the strength is decreasing, 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 like this. Correct. Here in this, all these are the waves. Here there will be thousands of waves like this. This is like a bundle is going, something like this. Correct. I have just put a one wave just to demonstrate. So what will happen here, that attenuation happens more attenuation you can see. Attenuation is more. Correct. Power becomes a, since here the frequency is less of the wave, power is less. Power of the wave is less here, because we are only operating between the few kilohertz and to few megahertz, and we know power is nothing but h nu. So if the frequency is less, energy will be less, power will be less of that. Now the good part is, the good part of these ground waves, that they can bend because their wavelength is very high. Wavelength is high. Wavelength is high. Why? Because the frequency is less. Frequency is less, and we know nu is equal to c lambda, na? So if the c is a constant, so nu is equal, nu by lambda is equal to c. So if the nu is more, lambda has to be less, isn't it?
So isn't mu c by lambda?
Yeah. C is equal to mu lambda. I have written wrongly. Velocity is equal to c is equal to mu lambda. Yeah. So if c is constant, if the mu is more, lambda will be less. Correct. So wavelength is here high. Now if we see, if you remember in the diffraction pattern, okay, when we were learning the diffraction, what we have learned in the diffraction, let's say this is the wave, it is coming, and here is the slit. Here is the slit. Then what will happen? In the diffraction, the light ray can bend like this. That's what we were getting, the diffraction pattern. And then we also calculated that how much will be this theta. And if you remember, this theta was nothing but a lambda upon A. This is what we calculated. Lambda is the wavelength which is the coming, and A is basically this aperture length, small a. Now what is happening here? We are interested here is, if the lambda is more, theta will be more. Theta is what? It is the bending capability. So if the lambda is more, bending will be more. So what happens? Let's say this is the obstruction. This is the obstruction. Now one wave is coming like this. What will happen? This will bend like this and will translate. Correct? So for an example, at your house also you would have seen. Let's say you are speaking. Correct? You are speaking and you have closed the door, but still you can hear, isn't it? How? Because the your voice is actually 20 hertz, 20 hertz to 20,000 hertz. That's it. That's the frequency of speech, 20,000 hertz. Now if you convert here in the wavelength, wavelength is bigger because frequency is less. So wavelength lambda is more here. So when the lambda is more, so let's say this is the obstruction K, what will happen? This will basically jump like this. It will hop. But if the wavelength is small, correct? Let's say wavelength is coming like this, then it can't jump. But if the wavelength is more, then it can jump easily. Correct? So this is the advantage of this. This is the advantage. That ground wave can actually jump the obstruction. Jump the obstruction. That's why whenever you see any kind of your neighbor is actually discussing or anything is happening, those are the very low frequency wavelength, low frequency waves, but their wavelength is much higher, so they can travel longer distance and they can jump actually. Okay, this is the property of the ground waves. Interesting, isn't it? Now, so this is basically this is the more about anything else is there in this. No, I think so. These are the few properties of the ground waves. Correct? Any doubt in this? Any query, concern?
So, sir, where do we get to see this? Like in local areas or something?
Yeah, so the ground waves where, yeah, application. So where the application is, application happens the ground waves. For an example, walkie-talkie. You see the police people, they are talking on the walkie-talkie. Correct? In your apartment, security people will also be talking. Correct? So where like a low modes, low frequency is there. Okay, we use this kind of ground waves. Okay, so it is not used for mobile phones. It is used only for the local areas, local communications. Okay, local area, very small area it will work. Okay, small areas. Okay, so this is how, for an example, your in your house, okay, in your house, some sort of a communication you would like to do. Sometimes we put a speaker, small speaker we put, and that it broadcast. Okay, it basically is doing at a small frequency, higher wavelength it can transmit. Okay, if you go in a local ground, okay, local, basically what we do, we put this kind of horn, na? Correct, we put here, and this is basically broadcasting everywhere. In the local area only we hear, na? Like in your house or neighboring house. That's it. This is the application of the ground wave. Here is also we are transmitting our wave. So there is a one transmitter, one receiver. Correct? Any further doubt? Any query?
No, sir, no more doubts. I think, yeah, that's it.
Okay, good. So now we are ready to move to the next kind of communication. We call skywave communication. Correct. Now, in order to understand the sky wave, we need to learn a little bit about our Earth atmosphere or the sky basically. Okay, because it is happening in the Earth. So let's understand how our Earth is actually. So when we talk about this is the Earth. Now, above the Earth, which are the layers of the Earth that you remember? Can you tell which are the layers? Do you see? In which atmospheric layer? Which layer?
stratosphere, and then
So which is the first one?
don't exactly remember, sir, but like I don't remember the order, but a few I remember and a few I don't. Stratosphere, and then uh, mesosphere.
So we live in the troposphere.
Oh yeah,
So troposphere is basically the first layer, correct? Where we all are living. Okay. So troposphere, it goes from this till 10 kilometer, 10 kilometer approximately. And this is the boundary where actually the aeroplanes are flying. Aeroplanes fly at the boundary almost at the of the troposphere. Okay. Now after that we get a one more layer. Okay, now we have the stratosphere. So till here we have a stratosphere. This stratosphere basically vary. Okay, this stratosphere vary till 100 kilometer. Okay, so till 100 kilometer. So till here, this is the 100 kilometer. So now we will do this in the different layers. So I will put this is, let's say, the region number. This is the troposphere. Then this I will divide into few parts. So let's say this is the part number D, part number E. Then I will put a one more which is a part number F1. Then I will put a one more which is a part number F2. Correct? What is this? So these two regions are stratosphere. Stratosphere. After the stratosphere, this region we call mesosphere. Mesosphere. And after this we get thermosphere. Thermosphere. And after that we get exosphere. Correct? So here we get an exosphere. Correct? So this is how the layers are actually looking like. Now we would like to understand the little property of this. So what are the properties? So the properties are, for an example, in this troposphere, okay, in this troposphere we are living, correct? So humans, like a lot of traffic will be there in this, because all the birds are flying, aeroplanes are flying, we are living, mountains are there, so much traffic is there, correct? Here the So if we go basically above the surface of the earth, we know that density decreases, isn't it? Density decreases. And why density decreases? Any thought?
now because atmospheric pressure decreases
Yeah, but why it decreases?
because you're having less mass per unit volume as you move away from the Earth. You're reaching out into space, so the amount of gas that's present keeps on decreasing.
But why?
Uh, because of their masses.
Because of the earth gravity. Earth gravity. Because earth is applying a force. And that force we have learnt is nothing but a gmm m1 m2 upon r square. R is increasing, force is decreasing. So here the particle which is there experience a less force, here it experience more force, correct? So they are more spread apart because there is a more volume. Okay. So earth gravity is actually ensuring whenever the particle is coming closer, it experiences a more force, so it come closer, closer, closer. That's the reason. So the density decreases as we go away. Now one more thing is, like, we would like to understand. So this is a 10 kilometer, this is approximately 100 kilometer. Mesosphere varies approximately some 170 to 190 kilometer, and X thermosphere varies, this one 300 kilometer approximately, 300 kilometer, and it goes till 400 kilometer also. My God. 400 kilometer above. Okay, so it's a huge number. This is how our earth atmosphere look like. Now we would like to understand that there are few phenomena are happening here. Now we know that sun will be somewhere here on the top. This is the sun, huge. This is the sun. Now sun rays are coming from here, ding, 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 in all the direction. When the sun rays are come, sun rays are having the very high energy, correct? And from the sun rays, all varieties of rays are coming. There are ultraviolet ray, infrared ray, visible light, radio waves, all kind of waves that we have learned. Correct? All kind of waves are coming. Now every wave has certain different energy, and that we can calculate based on frequency. E is equal to h nu. Now what will happen? Now if you give some energy to any particle, see finally these are the atmosphere is nothing but a air molecules, no? They are the air molecules. When you give the energy to them, what happens? They will get ionized, isn't it? So they will become ionized. The electrons will take that energy, will come out, they will become ionized. That's why you see this is called a thermosphere. We also call ionosphere sometimes, because here all the things are there ions. You will see only ions, positive, negative ions, correct? But the number of ions will be less. Why? So here is the less, here is the less ion. Question is why? Because the particle itself are less, na? Density is less there. Now as you go down, down, what is happening? Your ionization density will increase because the number of particles are increasing. So what happens? As you are coming from the this, it increases, so increasing. After some time, again start decreasing. Any thought why again this will decrease? It should increase. The number of molecules are increasing.
The ozone layer prevents the UV light from passing through, so ionization is not possible.
Ozone layer. The reason is because the intensity of the wave is also decreasing, na, as it travels. Okay, so if the light ray is coming, okay, light ray is coming 100 kilometer, its intensity will decrease, its power will decrease. Even though more molecules are there, but power itself is not there. How will you give? So what is happening? We get a maximum intensity somewhere in the middle, correct? And that's where actually we would like to do the sky wave transmission. That's where we would like to do, because there the intensity of the ionized particle is more. Okay, now let's see what we do. Is this clear as of now? Any doubt in this layer categorization?
So, sure, the total internal reflection occurs in the mesosphere.
Total internal reflection occurs. So in the ionosphere also, in the mesosphere also, in the stratosphere also, everywhere it happens. But generally we would like to do between this layer, like out of these three, somewhere in between we do, correct? Remember these names we have given, correct? Atmosphere doesn't know that my name is mesosphere, like that, isn't it? So that air particle is there, correct? He doesn't say, hey, I am from mesosphere, you can't come to me, you are in ionosphere. No, they don't know their name, isn't it? So that's the reason. So it be like in this layer, in between, somewhere in these two layers, correct, where the stratosphere is starting and the thermosphere is ending, in between somewhere in, we will get the maximum value. Okay, that's the intention. Now one more thing we should also remember is that, so this is basically one layer, this is the earth. We have 1 2 3 4 5. So this we wrote a troposphere, tropo, strato, we have divided into two parts. One we call the D, one we call the E. Then we have divided this one is the F1 and this one is the F2, correct? So this is also strato, this is the meso, and this is the thermo. Correct? This is what we did. Now the next part that we would like to understand, that when are these regions are creating, correct? So this one you see, troposphere is always there whether it's a day or night, doesn't matter. All the time you will have the troposphere, correct? This layer of 10 kilometer will always be there whether it's a day or night. Stratosphere will only be visible, or you will only be demarcated when in the daytime, when the sun is there. Night time, correct, we will not observe this kind of phenomena, correct. So it happens only during the daytime, it exists. In the night time it doesn't exist meaning is like that it will become the part of either the troposphere or the part of it is like a just a one layer. Okay, now the next one, this is, so this entire thing till entire this is also day entire. Now when we talk about the mesosphere, this also happens at the daytime, but in the night time it will merge with F2. That means in the night we don't have mesosphere at all. In the night we have only thermosphere we have. Mesosphere layer doesn't exist. Only during the daytime, whenever the cosmic rays are coming, whenever the sun rays are coming, this kind of demarcation we see. It is the sun who is creating this. It is the sun ray who are creating this kind of demarcation. Otherwise this doesn't exist. Okay, but when you talk about the thermosphere, okay, thermosphere, this happens whether it's a day or night, because it is very close to the sun, day and night. So always we will get the ionic form, whether any time 24 hours we will see the ions are here, 24 hours. But in this mesosphere only you will see during the daytime, not in the night time. Correct? That's what the property is. Now the question comes, what kind of layers they are working on. That is also, or what kind of waves they can take care of. So when we talk about here, this one, troposphere. This troposphere, this can be utilized. Okay, in this we do the transmission only up to, okay, for very high frequency we can do up to gigahertz. It's possible. Correct? Now what is going to happen when you go to the stratosphere? Stratosphere, what it does? Whenever the any wave is coming, if its frequency is low, what is going to happen? It will absorb that frequency. Okay, it will not be able to reflect. So what it does, stratosphere actually reflects, sorry, it will reflect low frequency, but absorb medium frequency and high frequency. It will absorb only the low frequency thing, will be reflecting back. So here the total internal reflection happens only for the low frequency. Medium frequency and high frequency, it will be absorbed directly. Okay, now why it absorb? Because after the absorption it will reach to this layer E, and here the reflection will happen. So reflect high frequency. So the reflection of the high frequency happens by E layer, the above layer of the stratosphere. Correct? Now the next thing comes mesosphere. What the mesosphere does? Mesospheres basically, it absorbs, correct? It will absorb high frequency, correct? It will absorb high frequency and then it will allow reach to them F2. And what happens here, high frequency is also reflected. Reflect high frequency. Correct. This is what kind of they are made up of. Few will absorb. See, the idea here is we should remember that as we go up, In order to reach up, you need a very high frequency. You need energy, na? More energy. If the wave is there, you want to send to the sky, correct? You need to have the high frequency, high energy. And high energy have the high frequency. So low frequency wave cannot reach here. Only high frequency wave can reach. Correct? So this is the basically one categorization that we have done. Are you getting any doubt in this?
Yes, no doubt.
Okay, fantastic. Now, once we understand this, now we will learn little bit more about the skywave communication. Let's understand that. So, skywave communication. The skywave communication, what we are doing in the skywave, the first one is the frequency that we are using for the transmission. It varies from a few megahertz. Few megahertz. Generally, we take greater than 10 megahertz to 30 megahertz, 30 or 40 megahertz, whatever we say. Correct? This is the frequency band in which we are putting. Now, what we will do here, we have the earth, and here we will put a transmitter, and this transmitter will basically send a wave. Correct? And here is basically the sky. These are the layers, and then this will come back like this on the earth. Correct? So this is basically we call skywave transmission. Correct? Now the question comes, in this case, when this wave is coming, when this wave is high frequency, what will happen? So let's say here we have sent one wave, we have sent one more wave, so this will go like this, and let's say it is covering here. We sent one more wave, it is going like this, and it is covering here. In this region, it will cover this region, this will cover this region, this will cover this region. Correct? So for an example, you have sent from here the wave, correct? This wave is actually going. From here it is reflecting back and it is reaching here. So it can cover this. But let's say you would like to cover much more bigger region. What you will do? You will put a many more receivers. So this is the receiver number 1, receiver number 2, receiver number 3. Many more receivers you will put, and you will get the as many as much skywave possible. Correct? That's how we do the skywave transmission. So here what will be, can you tell me which will have the high frequency, 1, 2 or 3? What do you think?
Mostly one and no, we know, 1 and 3.
1 and 3, correct. So 1 is slightly higher than that, so this mu1 will mu1 mu2 mu3. Here what we see, mu1 will be greater than mu3 greater than mu2. Okay, this is what we will get. Good. So this is how we basically try to do that. Now the next thing comes, we will discuss, is this clear? Any doubt in this?
Sir, how do you know why mu1 is more than mu3?
Because you are sending this to the higher height. When you are sending this to the higher height,
Right.
you should have the high frequency. Correct? So that's the reason. So as high it goes, it has the high energy. Now the next one comes the satellite transmission, satellite communication. What is satellite communication? It is utilized for more than 40 megahertz, more than 30 megahertz frequency, because then only it can penetrate all the layer and reach to the satellite. No? So if this is the earth, and here basically you have one layer, another layer, another layer, another layer, and here you have put a satellite. Correct? Satellite. Now earth rays will go here, ding 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 till here, and then from here it will come back. like this. Alright. So that's how basically the satellite communication happens. Satellite communication, and here it happens mostly from ionosphere. 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 Correct? Ionosphere, because ionosphere is reflecting back. It is basically penetrating above that. It is penetrating that, and it is happening more efficiently. Okay, here the frequency is very high, so nu is very high, very high. What about the lambda? Lambda will be how much? High or less?
Less.
So the lambda is less. Now if the lambda is less, then what will happen? Theta is equal to lambda upon A as per diffraction. Lambda is less, theta will also be less. So that means what will happen? This will not expand. So if any obstruction is coming, then it will not be able to get that. So for an example, let's say you are here, correct? And something obstructed that signal. Okay, let's say you are inside the lift. Now this signal cannot come to you, and that's why in the phone what do you see? Signal not there. You observe na, sometimes in the lift you are there, signal is not there. Why? Because this is the high frequency, it cannot penetrate. Even though sometimes your lift door is open, let's say door is open, this is the door and it is open, wide open, but still since these rays are coming like this, they cannot bend because of the high frequency. So what will happen? You will see the signal is not there. Okay, nowadays you will be seeing that there is a lot of signal issues, isn't it? Because many people are using the communication, all this communication we are learning because of this communication only, isn't it? And this is happening at a very very high frequency, very high frequency it is happening. Getting? So for an example, when you are having the Wi-Fi at home,
Yes, sir.
what is the speed?
Mm, they say it's 100 Mbps, but
Ah,
it's actually not.
100 Mbps. What is the meaning of this? What is Mbps meaning is?
Megabytes per second.
What is the meaning of that?
That means that much data is being transmitted every second.
What is the meaning of mega?
Uh, yeah.
10 to the power 6 bits per second. My God. So this is equivalent to megahertz. Correct? Megahertz. So that means your data transmission is happening in 1 second. This is 10 to the power 6 means 1 million times. Correct? So 1 million of data is actually getting transferred from here to your house. Currently, whatever I am speaking, so much of the data is getting transmitted to you. My God, isn't it? So this is happening because of the communication. Okay, this is a very very faster communication, very speed. Now once we get this, now we are ready to. In this satellite communication, there are multiple types. Let's understand that. Suppose you are here. Let's say you are here. Now, in the satellite, now question comes, can this satellite communication we do at our ground? Is that not possible? Answer is, let's say, whenever here is the satellite. We know that whenever you are transmitting any signal at a high frequency, that means what will happen? Lambda will be small. If the lambda is small, what is going to happen? Theta is equal to lambda by A as per diffraction pattern. If the lambda is small, theta will be small. That means it can't bend. Correct? Signal can't bend. So if the signal is coming like this, it cannot take a hop and can go like this. It is not possible. Correct? it is only possible when the lambda is bigger. Okay, if the lambda is bigger, then only. So if let's say this is the signal coming, I have put obstruction, can it pass?
No, sir.
No. But let's say I have put a same ball, but if the signal is like this, see, it easily passed. Correct? Why? The wavelength is bigger. This is the wavelength now. Lambda is bigger, and here this is the wavelength, smaller. That's the reason. If the bigger wavelength, it can easily pass. Why? Because the theta is more as per diffraction. So what happens, since this satellite communication is happening at a very high frequency, so suppose I would like to send this signal like this, what will happen? Correct. This signal, because of the radius of the curvature of the earth has the curvature. Now what will happen, that we cannot see, this is, let's say I have put a one signal like this. Correct? It can only be transmitted in a line of sight. If you can see that antenna, you can observe that. But let's say if this is the scenario is happening, let's say one signal is here, and then you transmitted here. Correct? What will happen? Can you think like that this antenna can receive this? Can we say
No,
so?
sir. No.
No, it can't receive. Isn't it? It can't receive because here there is obstruction. This signal cannot go like this, and okay, this signal will never go something like this. It will not do that. Why? Because it is of very high frequency. Very high frequency means it is coming like this, ding 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 ding, ding, stopped. Correct? But if it is of low frequency that we done in the ground wave, then what will come? It will come like this, ding ding ding, it will reach. Now the question is, then what should we do? Okay, what should we do? Now one more thing is, let's say if we increase the height of the antenna, so what we will do, generally, if you have the, let's say, lambda wave, lambda is the wavelength, then the antenna that is required is the lambda by 4. This is the lambda by 4 should be right. So whenever there is any kind of wavelength, any kind of wave is there whose wavelength is lambda, generally the height of the antenna which is required to do that, for an example, this is the wavelength, na? Like this. Now this height, which is the antenna which is transmitting, should be lambda by 4 minimum. Correct? So, and we don't want that. Suppose if I have, let's say if I take some 20 hertz, 20 hertz, correct? Can you calculate what will be the wavelength for this? 20 hertz frequency wave is there. What will be the wavelength? How will we calculate? C is equal to nu lambda. So lambda will be what? C upon nu. So lambda equals C is how much? 3 into 10 to the power 8 divided by 2 into 10. So 1.5 into 10 to the power 7 meter. That means 1.5 into 10 to the power 4 kilometer. That means 15,000 kilometer. Can you actually create an antenna which is 15,000 kilometer? Is that possible?
No, sir.
It is not possible. Earth radius itself is a 6,400, isn't it? That means it is not possible. As the frequency reduces, our wavelength increases, and height of the antenna required to do that will be much higher. So that means it is not possible. So what we do here is, we basically, let's say this is our earth. This is our earth surface. And here what we do, let's say this is the This is the one antenna which I have kept. This is the another antenna. So this is like transmitter, this is the receiver, isn't it? Now this is the distance. This is the distance, let's say, is S, and this is the height of the antenna is H. I can say HT, transmitter height, and this we can say receiver height, HR. Now what we want to calculate? We want to calculate how much is the range, correct? How much is the range of this? Up to what range actually any antenna can transmit? You have seen that there are so many, like if you take any kind of subscriber like a Airtel, Reliance, any kind of people, if you see like they have the many transmitting antennas. Whenever you go on the road, do you see those things? Do you see those transmitter? Bigger antennas are there, correct?
Yeah.
Now those antennas, they keep at a different distances. Question is why? Why they keep like that? So that they cover the entire range. Sometimes you will be seeing in some of the areas you are not getting any range. Then you will basically complain, I am not getting a range. Those people will come, will check, okay, what is the strength? And then they will put a one more antenna there. Correct? So what happens actually? It increases the range. How? Let's say this is the height of the antenna. We know that Earth is the center here, O. This is the radius R. We can also join here. This will also be R. So this is the H. Now what kind of, this became a triangle and this will be 90 degree because radius and tangent are 90 degree. Now I can apply Pythagoras here. So apply Pythagoras. What that will be? R plus HT whole square is equal to R square plus S square. Now I will open this, so I will get R square plus HT whole square plus 2RHT is equal to R square plus S square. R square cancel. Now if you talk about in in comparison to the radius of the earth, this height of the antenna will be negligible, na? Isn't it? And if you are doing the square of that, this will be further negligible. So we can ignore this. This is approximately equal to 0. We can ignore. So neglect basically. So S will be how much? Square root 2 times radius HT. This basically is the range. Correct? So this is the range of one antenna which is of height T. Correct? And if the radius of the earth is this is the range up to which it can broadcast. This is how these subscriber actually calculate that, okay, what is the nearby station? Okay, what is the nearby station? Okay, this is the distance. Okay, up to 1 kilometer, 6 kilometer this can transmit. Then after that they will put a one more antenna. After that one more antenna. After that one more antenna. Like that they will do. Correct? That's how they do. Now, suppose, and then after this what will happen? We will put a, so this antenna will further enhance. Right? This is how basically we can do that. Now, so let's do a one small question based on this. Okay. So let's say I am saying there is a transmitter. This is the transmitter antenna. Transmitter antenna. This has the height of 32 meter. Correct. And there is a receiving antenna also here. There is some receiving antenna which is on the earth surface, and this height is 50 meter. Correct. Find out what is the maximum distance between them. What will be the distance we should put between them so that the effective communication is happening. And radius of the earth, we know that it's a 6,400 kilometer. Give it a shot. So it's like this. One antenna is here. H of transmitter, H of receiver. Now give it a shot. Any idea how you are doing?
I'm finding the range for both and transmitter and receiver.
Yes, fantastic. Good, good, good. So let's say this distance is S1, this distance is S2. Evaluate S1 and S2 and add them. So total distance will be S1 plus S2, and that is nothing but a 2h of transmitter into radius plus square root 2 of h of receiver into r. Correct? So now what we can take common will be 2 times of r bracket square root ht plus square root hr. Now square root 2, 6,400 kilometer, and then 10 to the power 3. This is what we got in meter. Then bracket ht will be square root 32, correct, plus square root 50. This is what we will get. Now this will become 880 will come outside, and then 100 will come square root 20, and then this one we can write out chok 4 root 2, and this will be 5 root 2, isn't it? So what we can write here is this will become 9 root 2, so 800, and this we can write 10 2, so 5 4 2 root 5, 2 root 5, and then into 9 root 2. So basically 18 into 800 into square root 10. This is what we'll get. So this became 118 guna 8. So now 18, so 144 00 square root 10 meter. So now this will be approximately 3 14 42, yeah, approximately you are going to get 45 kilometer, because this is 14 kilometer na, approximately 14 times 3 is 42, and then we will get this is a 500 meters, so 1.5 more will be added, so approximately 45 kilometer. So that means these two antenna can cover the 45 kilometer distance, isn't it? Correct. So this is how basically we do these kind of calculation. So there are three modes of transmission we have learned in summary. First one we have learned called the ground wave, which works only from kilohertz to 10 megahertz. Correct? Here the attenuation is more. Attenuation is more. Then we learned we call sky wave. Sky wave works till 10 to 30 megahertz. Correct? But the problem here is in the sky wave that this bandwidth is small. Bandwidth is small. In this small bandwidth, we cannot utilize all our devices, all the phones, TVs, correct? There are so many electronic equipment nowadays for military application, for weather application, for this application, correct? There are so many applications are there. This bandwidth is small. So then we go to the space wave, or we also call satellite wave, correct? In this we go greater than 30 megahertz, 30 or 40, whatever we say. And then in this case we can utilize this for any of this. Now in the space wave we have learnt a one more called line of sight. Whatever just now we discussed, this is called a line of sight, because we can see this antenna to this antenna, then only the transmission will happen, otherwise it will not happen, correct? This is we call line of sight, line of sight, correct? So everyone has their own application. This one we utilize for TV, cellular phones, correct? TV and cellular phones, it is utilized. Sky wave is utilized for, like for an example, nowadays most of the things we are using this, but sky wave is also used some sort of a weather forecast, some sort of any kind of radio stations, they use the sky waves. Ground waves is used at our local level, like a walkie-talkie. Any local area is there, broadcasting is there, like that. Line of sight is utilized by the phone, telephone communication, correct? So, which is on the ground. Whenever we are doing, we call the line of sight communication, correct? These are the few methods of propagation. Methods of propagation of wave. Any doubt, any confusion, or is it clear?
No, sir, not out.
Okay, fantastic. Now we will discuss little bit about we call modulation. Okay. Question comes, what is modulation and why it is required? What is the use for modulation? Any thought what is the meaning of modulation?
Like increasing or
That is called amplification.
sorry, something related to persistence.
No, resistance. So okay, let's understand first the need, then you will realize what is the need. So the first need is whenever you are communicating, correct? There is a limitation on the size of antenna. How much should be the size of antenna? Size of antenna, correct? So size of antenna meaning is like that if you have the low frequency message, low frequency message, and you would like to send this to somewhere, correct? So for an example, just now, let's say you are speaking on the phone, you are speaking on the phone. What will be your frequency approximately when you are speaking?
Somewhere around megahertz.
Oh my God.
I'm sorry, sir.
Speech. What is the speech frequency?
Okay, wait, 20 to 20,000.
Pardon?
20 to 20,000.
20 to 20,000 is the hearing frequency. You hear. But what your speaking frequency? When you are speaking,
Around 20.
around 20. So that is, so when you are speaking, you can go maximum to 2000 to 3000 frequency. That's it. When you are speaking, not more than that. Correct? So it is very less. Let's assume you are speaking at 1000 hertz frequency. Assume. Correct. Now if we calculate based on this, how much will be the wavelength? Wavelength will be how much? C upon this 1000. C is 3 into 10 to the power 8, so you'll get 3 into 10 to the power 5. That means you need how much? 300 kilometer approximately. Now if I calculate the lambda by 4 of this wavelength, correct? So lambda by 4 will be approximately 75 kilometer. 75 kilometer height of antenna you need. Is that possible to have that? 75 kilometer. It's impossible, isn't it? You stay on which floor?
Sir, fourth floor.
Fourth floor. Okay. What and how many floors are there in your tower?
Total 7.
7. Okay. What do you think will be the height of the tower will be, or height of your tower approximately?
You mean the whole building, sir?
Yes, yes, whole building.
Uh,
So let's say 1, 2, 3, 4, 5, 6, 7. Like from ground, how much this will be approximately, just to get the feel. Do you think will it be 1 kilometer?
no, sir, it won't be 1 kilometer.
Okay,
Not
then
even 1 kilometer.
pardon?
It can't be 1 kilometer. That's
Oh,
like really high.
okay, so then half kilometer.
Yeah, sir. Or a bit less.
Okay. Now let's assume what is your height in meter? What is your height in meter or in centimeter?
Okay, 177
177 is what? Centimeter or meter?
centimeters, sir.
So approximately assume your height is 2 meter. Correct? Assume 2 meter. Now in your house, let's say this is the one bhupesh. I am asking one more bhupesh to stand over this. I am asking one more bhupesh to stand over this. How many bhupesh can stand? So you reach from ground to ceiling. What do you think? Is 3 bhupesh enough or more than 3 is required? What do you think? Just have a look.
Sir, to the ceiling, sir.
Yeah, yeah, correct, correct, correct. In your
Yeah,
ceiling.
okay. 2.
2, 2 or 3? I'm asking.
2, sir.
2. Okay. So that means 2 became a 4 meter, isn't it? Now how many floors are there? 7 floors.
Yes, sir, yeah.
How much came?
28 meter.
Oh my God. 28 meter. Let's assume it is a 50 meter. Assume. Okay. Or no, let's say 30 meter. We are giving 2 meter extra. That means your entire building is just a 30 meter. 30 meter. What we are talking about? 75,000 meter. Is that possible to create an antenna? No, it is not possible. Correct? Like my apartment is approximately, I have the 26th floor in my apartment. 26 floors. That means what I can do is 4 meter multiplied by 26. Correct? Approximately, let's say 102. This is coming 102 approximately, but let's assume 120 meter. But still this is 75,000. Not even 1,000 meter we are getting anywhere. It's a very, very huge. Correct? Do you know what is the tallest building in the world? Tallest building. What is the height?
Burj Khalifa.
Okay, what is the height of that?
Not sure, sir, but that's the highest.
Okay, so let me give you the height. Uh, Burj Khalifa height. Yeah, Burj Khalifa height is 828 meter only. My God, isn't it? So that means even building a 1 kilometer high antenna is impossible, isn't it? You cannot make a 1 kilometer, forget about 75 kilometer. It's not possible. That's the limitation. So that means we can never, does that mean we can never transmit your voice to your aunt? But we do that, isn't it? Question is how? That's another question, correct? Now the next thing is, whenever any antenna is there, let's say this is the antenna. This is the antenna, correct? This antenna is there. Now, if you see how the power is radiated, when it is radiating the power in all the direction, like this, it is radiating in all the direction. So what is happening? See, for an example, you have a power 100 joule, correct? So, or assume like you have the 100, which sweet you like? Laddu, kaju katli, which one? Anything or whichever you like.
Sure, any sweet.
Which is your favorite?
Say, laddu.
Laddu, okay. So let's say you have the 100 laddus and you are distributing this to so many people. What will happen? Every person will get the less number of laddu than 100, na? Isn't it? Same thing, you have a certain amount of energy of the signal. So you have one signal whose frequency is nu, you have the E is equal to h nu, correct? Now what is going to happen? When you are transmitting this, you are transmitting to many people. So what will happen? Its energy will reduce. So here the energy that the receiving tower is there, its energy will be less in comparison to the energy which is at the source, isn't it? So what is going to happen? That if we want, we know, if we want that here we should get the sufficient energy, then what should happen? Here we should have the high frequency, isn't it? High frequency, if it is there, then frequency will decrease. By the time it reaches, it is sufficient enough. Let's say Bhupesh is needing the 10 laddus, correct? And there are 10 people are here, 10 people. So in order to get the 10 laddus, at least here the 100 laddus should be there. Then only it will reach, no? 10 will get distributed. But here itself is like a, let's say I get 50 laddu. Is that possible that you can get a 10 laddu each? Not possible, isn't it? So that means what is the need? We need here high frequency. High frequency should be there. Previous case, what we need? We need the high frequency so that the antenna's length will be less. We need a high frequency. Here we need the high frequency. Now the next thing is, suppose when you are sending the signal, this is basically your tower. From the tower the signal is coming. 1 signal, 2 signal, 3 signal, 4 signal. Now this tower is sending only your signal, or it can send your friend signal also, no? So that means here one signal is coming like this also, and one more signal is coming like this also, another signal is also coming like this also. So that means there can be mixing of signal also. It is quite possible, isn't it? What you need, that mixing shouldn't happen. Mixing of signal shouldn't happen. We don't want that. Okay? Sometimes you have you ever faced that you get a call from someone, let's say you called your aunt, but actually call dispatched to someone else, and they are saying, yeah, how are you doing? And that is somebody else. Has it happened to you anytime? That is called cross connection.
Sure, happens like every year.
Correct. Very rare happens, but it may happen. But we don't want. Okay. This is basically mixing of the signal. This mixing of the signal will only be avoided if you have the separate channels. Like for this, there is a separate pipe. Correct. That means what we should say, distribution of bandwidth, distribution of frequency should be there, should be there. What is the meaning of that? Meaning, like, suppose we will say to the Bhupesh, okay Bhupesh, you will actually operate between frequency number 1 to frequency number 2, and then you will tell your aunt, okay, you will operate from 3 to 4. Somebody else you will tell, okay, you will operate from 4 to 5, like that. So there will not be any cross connection, cross connection, correct? Now, if in all three things what we observe, this can only be done by a high frequency. We need the high frequency for this. Now the question is that when you are speaking, your voice is coming in 1000 Hz. How can we increase this frequency? What should we do? Should we put some device in your throat so that your frequency increases? We can't do that, isn't it? We can't put here some device which will increase our frequency, because that is the nature has made us. And then we process we call modulation. Okay, modulation. Modulation is a very interesting process. In simple word, what the modulation does, modulation, you have the one wave. Let's say your signal is there. This is the signal, correct? Modulation is nothing but it will basically provide you a high speed car, high speed car basically, or high speed carrier, I can say, high frequency carrier, high frequency carrier. So you put your signal on that, this carrier will take with a high speed and will reach to the destination, correct? For an example, you want to go from Bangalore to Delhi, correct? What do? You basically land in the aeroplane. Aeroplane goes with a faster speed, it take you destination. Aeroplane is like a carrier for you, isn't it? It's a high velocity carrier. Similarly, we utilize called modulation. Modulation means we utilize a one wave we call high frequency wave, high frequency wave, and this we call is the carrier wave, carrier wave. In this wave, you basically put your signal which is of low frequency, low frequency, and low frequency signal you put on the high frequency wave. This wave will basically take you and will reach to the destination, and then you will basically take out the low signal wave from it and done. So what happened here? You have done the high frequency transmission, and for high frequency transmission, lower size antenna is fine, isn't it? We can use the lower size antenna. We can use what do you call? We can use basically this one. We can also use uh, lower size antenna. We can utilize basically effective power, because the power will also be more because you are going in the very high frequency, isn't it? So this is basically a simple fundamental of modulation. Now let's there is a mathematics involved behind this. We will discuss that mathematics in the next class, okay, in detail, that what is the how modulation happens, what we do, what are the different phenomena we should take care of, correct? So I think it will take mostly one more class, and we will try to finish in the next class for sure. Okay, so your entire syllabus is going to get over. Congratulations, that's good. But now this is not the end. This is just a start, because now we need to compile everything and learn. Okay, so your chapter wise revision is going on. Up from the next week, what we will do, all the tests that you have done, okay, I'm going to correct by the time, and let's discuss what are your doubts. We will discuss your doubts, and once we finish this chapter wise revision, we are going to start the test series for you.